The universe does not hide its past. It carries it everywhere. Every beam of light moving through space is a memory traveling across time, preserving moments that vanished billions of years ago. When we look into the night sky, we are not seeing the universe as it exists now. We are seeing echoes, ancient signals crossing impossible distances to reach us long after their origins disappeared. Some of that light began its journey before Earth existed, before oceans formed, before life had a name. Space itself becomes a living archive, and every star is a message sent from another age. Humanity once believed the early universe was simple, a dark and chaotic place slowly organizing itself over billions of years. According to the foundations of modern cosmology, the universe began nearly 13.8 billion years ago in an event so violent and extreme that space and time themselves emerged from it. In the beginning there was only heat, energy, and rapidly expanding darkness. As the universe cooled, particles formed. Hydrogen and helium spread across the cosmos like endless invisible oceans drifting through space. Then came silence. For millions of years, no stars burned. No galaxies existed. The universe entered an era known as the Cosmic Dark Ages, a time before light illuminated the heavens. Matter floated through endless darkness while gravity quietly worked behind the scenes. Tiny fluctuations in density slowly pulled gas together. Clouds collapsed inward under their own weight. Temperatures rose. Pressure increased. And eventually, the first stars ignited. Those first stars were unlike anything alive today. They were enormous, unstable, and unimaginably violent. They burned with terrifying intensity, flooding the darkness with the first true light the universe had ever known. Their deaths triggered colossal explosions, scattering newly forged elements into space and laying the foundations for everything that would come after. Galaxies began to emerge from the chaos, but scientists believed these early systems would be primitive and disorganized. Complexity, according to theory, required time. Then humanity built a machine capable of looking deeper into space than ever before. The James Webb Space Telescope was designed to peer into the ancient universe itself, capturing light that has traveled for billions of years. Scientists expected to see the first rough stages of cosmic evolution. Instead, what appeared in the data shook astronomy to its core. Ancient galaxies emerged with impossible clarity. Some contained organized rotating structures. Others appeared massive, bright, and unexpectedly mature. A few even hinted at spiral formations that should not have existed so early after the birth of the universe. These were not tiny chaotic fragments struggling to form. They looked evolved, structured, ancient beyond expectation. At first, researchers suspected errors. Perhaps the distances were wrong. Perhaps the light had been misinterpreted. But observation after observation confirmed the same disturbing reality. These galaxies existed only a few 100 million years after the beginning of everything. On cosmic timescales, that is almost instantaneous. The deeper Webb looked, the stranger the universe became. Inside these distant galaxies, scientists discovered heavy elements such as carbon, oxygen, and iron. Elements that should not have existed yet. These materials are created inside stars and spread through explosive deaths over immense periods of time. Yet somehow the early universe already contained them in abundance. This suggested that stars were forming, burning, and dying far faster than current theories predicted. The young cosmos may not have been calm and gradual. It may have been a place of relentless transformation, where creation unfolded with shocking speed. Then came another mystery. Supermassive black holes appeared in the distant universe far earlier than expected. Some were already billions of times more massive than the Sun when the cosmos itself was still young. According to existing models, objects of that size should have required far more time to grow. Yet there they were, lurking inside ancient galaxies like enormous shadows born too soon. Scientists began searching for explanations. Perhaps black holes formed differently in the early universe. Perhaps unknown forces accelerated their growth. Or perhaps something deeper about cosmic evolution remains hidden from us. No theory fully explains what Webb is seeing. And still the mysteries continue. Invisible dark matter may shape galaxies like an unseen framework beneath reality itself. Strange gravitational effects guide cosmic structure across unimaginable scales. Complex carbon molecules drift through interstellar space billions of light-years away, suggesting the ingredients for life existed long before Earth formed. Everywhere we look, the universe appears more active, more organized, and more mysterious than anyone expected. What makes these discoveries so unsettling is not simply what they reveal, but what they imply. The universe may have evolved far faster than our models predicted. Order appeared early. Structure emerged quickly. Complexity rose from darkness almost immediately. The deeper we search into cosmic history, the less certain our understanding becomes. Every photon collected by Webb carries a fragment of that forgotten age. These signals traveled across expanding space for billions of years, surviving long enough to arrive here, where human eyes could finally observe them. They are ancient whispers from a universe that no longer exists, fragments of realities erased by time yet preserved in light itself. Humanity built a telescope to study the origins of the cosmos. Instead, it may have uncovered evidence that our understanding of those origins is incomplete. Somewhere within that ancient light, hidden inside the earliest structures ever seen, lies a deeper truth about the universe. A truth we are only beginning to glimpse. And the most unsettling part is this. The farther we look into space, the closer we come to realizing how little we truly understand about existence itself. There is something deeply unsettling about the idea that the universe may have become structured too quickly. Not slightly faster than predicted, but so rapidly that entire chapters of cosmic evolution appear missing. It is as though humanity opened a history book expecting to find scattered ruins and primitive beginnings, only to discover vast cities already standing in the darkness. The timelines no longer fit comfortably together. The universe is revealing signs of maturity at an age when it should have barely awakened. And this raises a terrifying possibility. What if the early cosmos followed rules we still do not understand? For decades, scientists believed they had a reliable framework for how the first galaxies formed. Small clouds of hydrogen collapsed under gravity. Tiny stars ignited. Over immense stretches of time, these stars merged into larger systems, eventually creating the galaxies we see today. The process was expected to be slow, chaotic, and inefficient. But the James Webb Space Telescope is showing something very different. Some ancient galaxies appear not only massive, but strangely ordered. Rotating disks already existed. Dense clusters of stars formed far earlier than expected. Even more disturbing, some galaxies seem to have stopped forming stars surprisingly early, becoming stable long before the universe should have allowed it. It is almost as if cosmic evolution accelerated in ways modern physics cannot fully explain. Scientists are now questioning assumptions once considered untouchable. Dark matter, the invisible substance believed to hold galaxies together, may behave differently than current theories predict. Some researchers suspect it may have clumped matter together much faster in the early universe, acting like a hidden gravitational network guiding the birth of cosmic structure. Others wonder whether the first stars were far larger and more violent than previously imagined, producing enormous amounts of energy in extremely short periods. But even those explanations struggle to account for what Webb continues to uncover. One of the most mysterious discoveries involves light itself. When astronomers observe extremely distant galaxies, they are not simply seeing stars. They are studying ancient radiation stretched across billions of years by the expansion of space. This stretching creates what is known as redshift, a kind of cosmic fingerprint that reveals how far back in time we are looking. Some Webb observations show galaxies with redshifts so extreme that they appear to exist shockingly close to the beginning of the universe itself. And yet these galaxies already seem evolved. It is a contradiction that should not exist. Some researchers have cautiously suggested that our measurements of cosmic expansion may be incomplete. Others propose that unknown processes shaped the early universe in ways hidden from current models. A few even question whether the timeline of early cosmic evolution needs serious revision. None of these ideas are small adjustments. They would fundamentally reshape humanity's understanding of how reality itself unfolded after the Big Bang. Then there are the black holes. Deep within certain ancient galaxies, Webb detected evidence of enormous black holes already feeding on surrounding matter. These objects release immense energy, outshining entire galaxies as material spirals into them at nearly the speed of light. But according to current theory, black holes that massive should not have had enough time to form. So how did they appear? Some scientists now believe primordial black holes may have formed directly from dense regions of the newborn universe itself, bypassing the normal life cycle of stars entirely. If true, these objects may have existed almost since the beginning of time, silently shaping the growth of galaxies from the shadows. Others believe there could be unknown mechanisms allowing black holes to consume matter far more efficiently than expected. But no explanation feels complete. The deeper humanity investigates the early cosmos, the more reality begins to resemble something unstable, unfinished, almost hidden behind layers we cannot fully perceive. Every discovery answers one question while creating 10 more. Webb was supposed to sharpen our picture of cosmic history. Instead, it has exposed fractures within that history itself. And perhaps the strangest realization is this.